ventricle, and we're going to say that in this cardiac cycle, there are two phases. The first phase is the relaxation phase. We're going to refer to this as diastole. And again, just for emphasis, I'm talking about the left ventricle. We could be talking about the left atrium or the right atrium or the right ventricle, but we're focused in on the left ventricle. Every one of those chambers has a phase that we would refer to as diastole. During diastole, this is a rest phase. And during this rest phase, the left ventricle fills with blood. So I'm going to put ventricular filling. Now, what I would encourage all of you to do is just sit down, study this material well in advance so you can give yourself time to think about the logic. If the left ventricle pumps blood out, then there must be a phase where it fills up, right? Because if there wasn't a phase to fill up, you'd have no more blood to pump out. So there's got to be this phase where it can fill up with blood. What do we call that phase? Diastole. Don't call it diastole. That's what the Russians drink every morning, okay? Hopefully nobody's in here Russian. If I offended you, I apologize. So diastole. We could sit there and talk about ventricular diastole. We're talking about the phase where the left ventricle and the right ventricle are going to fill with blood. Now, once they fill with blood, now they can contract and inject that blood out to, in the case of the left ventricle, the systemic circulation. So that's our second phase. And we're going to refer to this as systole. Don't call it systole. That's what the Russians drink in the afternoon. So they got their breakfast of champion in the morning, and then they got their lunch of champions in the afternoon. And of course, if you paid attention to anything in sports, what could you tell me about the Russians this last week? No sports fans, Miss Chan?
Nope.
What's that? They're dopers? Doping, that's right. As a matter of fact, the International Federation came along and basically sat there and said, all Russian athletes banned from international competition for the next year. And in case you don't know all the history, during the 70s, the Russians had women, Ms. Cho, listen to this, who were swimming against people like you, and they were all 9 feet tall. These were women, and they go, "Hi, my name's Lasvana." Okay, back to the story. Systole, this is the work phase. You think I'm joking about it? You go and read about the Russians and the East Germans. The work phase, this is where we have ventricular ejection. Okay, simple enough. Now, let's see here, Miss Savannah. What will you call the volume of blood in the ventricle at the end of diastole? What would you call that? The question I have for her and for all of you is, what are you going to call the volume of blood in the ventricle at the end of diastole? We'll see if she can make it on Trivial Pursuit. You don't know? Well, that's not the correct answer for sure. Any good Trivial Pursuit players?
Diastolic volume.
The what?
Diastolic volume.
Nope.
End diastolic volume?
What's that?
End diastolic volume?
You're cheating. He's looking at the notes. Is that what you're looking at?
No.
No?
Google.
Good.
No.
Okay, good. Good. He says end diastolic volume. You get 10 extra credit brownie points for knowing that, for looking at Google. End diastolic volume. Now, Mr. Smarty Pants. I mean, what are you going to call the volume of blood here at the end of systole?
At the end of systole?
At the end of
And
systole. Come on, it's simple. If we have end diastolic volume, then we must have
and systolic
and
volume.
end systolic volume. So here, I'm going to put EDV, end diastolic volume. Come to you here, Leroy, in a second. And then up above, we have end systolic volume. Listen carefully. What is EDV? That's the volume in the ventricle at the end of diastole. What is ESV? It's the volume of blood in the ventricle at the end of systole. Leroy's over there quickly Googling now. So we're going to talk about stroke volume. Take a look. They're all eyes up here. Going around here is one stroke. Stroke volume. If you sat there and thought about a pump, and a pump going through a stroke, the volume of blood or liquid or gas pumped out during that stroke would be called stroke volume. So, Leroy, give us a formula on how to calculate stroke volume. Say it louder.
The stroke volume equals the ESV plus EDV.
Okay. So he's got a formula that says stroke volume is equal to ESV plus EDV. Was that correct? Is that what you said? Mr. Lou, you want to help him out? No? Let's see here. Miss Melissa. Does that formula look right to you? The volume of blood pumped out of the ventricle in one cardiac cycle is called stroke volume. And the formula for stroke volume reads SV equals
How's a Google answer?
Sorry. I would add it.
Miss Mullen? I think that would be the correct answer. And by the way, you don't have Google up, do you? Excellent. Good. Kudos to you. So she said that it's ESV minus EDV. Right? The other way around. EDV minus ESV. Let's sit there and think about Logic 101. Here's the blood volume I start with. Here's the blood volume I end up with. The difference between those two has to be the volume of blood that was pumped out during that cardiac cycle. Yes? No? Maybe so? Eric? If this is what I start with, now the heart contracts and pumps blood out, and now I measure the volume of blood left in the ventricle, then the difference between what I started out with minus what I'm left with has to be the volume of blood that was ejected out of the ventricle for that cardiac cycle. Yes? Good job, Lily. So that's our formula. It says that stroke volume equals EDV times minus ESV. So let's come back over here now to our model, to our 5-step model. And if I ask all of you tonight what step number 3 is, Mr. Nate or both of you can tell me step number 3 is known as what? Oh, see, I was being very optimistic, as in you would all be able to tell me the answer. Ms. Ivy, you can tell me what? Gas transport, that's correct. Good job. Gas transport. Vincenzo, look at those notes. Good job. What's the determinants of gas transport? There's 2 of them.
Cardiac output.
Okay.
And oxygen content.
Good. Okay. Excellent. So, cardiac output. And now we return to our expert, crack, super duper cardiovascular physiologist, Miss Mullen. See what happens when you do so well? What's the formula for determining cardiac output? Well, that's stroke volume.
Oh, it's liters
Beep.
of blood over
Beep.
seconds?
Beep. Somebody gonna resuscitate Mrs. Jones?
Pressure difference over resistance.
What's that?
Pressure difference over resistance.
Oh, still baseline. Ms. Samantha?